Okay, so we've looked at frequency distributions, we looked at histograms, we've looked at frequency polygons, we've looked at ogives. Okay, there are still lots of other ways to graphically represent data, and we're going to look at a whole bunch more of those today. Okay, the first is a bar graph. Now, you might be thinking, well, isn't a histogram a bar graph? Yeah, kind of. It's a specific type of bar graph. But a bar graph can also be horizontal bars instead of vertical bars. Okay. They don't always have to be crammed in right next to each other like they are in a histogram. There can be spacing. But again, it still shows frequency. It's still a way to represent a frequency distribution in a graphic form. Just so happens that the way that it gets represented is not as strict as a histogram. And here's a quick little example of what one might look like. Again, notice the bars are going horizontally now instead of vertically. Frequency might, here's our frequency down here, the number of people that use this mode of transportation to get to work. And obviously this is in an area that has a train and trolley to get to work. It's not going to really work here in Fort Myers. If you try to take the train to work, you're not going to end up I'm not going to end up here. Okay? So here's an example. That's one example of a bar graph. Again, it's still based off of frequency, but when you do it horizontally, notice the frequency goes on the x-axis instead of the y. When we do it vertically, the frequency goes over here, but when we do it horizontally, the frequency goes over here. So that's the first type, bar graph. Okay. Second type is called a Pareto chart. Okay, and this is more like a histogram, except it gets rearranged so that the category or number that appears the most starts first, and you sort of work your way down to the right. So in a Pareto chart, you actually have to rearrange them in order of highest frequency down to lowest frequency. It'll look like this. So it'll always have that sort of stair-step look, unless there's not a significant difference between the highest frequency and lowest one. Okay. If there are two highest frequencies that are the same, so for example, if these two were the same, if it's a category, you'd put them in alphabetical order. Okay. But most of the time, you wouldn't use a Pareto chart for something where the bunch of them were the same, where it was more uniform. You'd use it to show that difference. And again, this is a way to help us do some analysis. Of course, in this case, people taking the bus was second. People taking a car was the highest frequency. But again, now we're back to having frequency on the y-axis and our categories on the x-axis. Okay, so that's a Pareto chart. Again, we're still doing it in terms of frequency. So we've looked at the frequency. Maybe we've made a frequency distribution to decide how high some of those things go, and that helps us order it and put it in a chart. Okay. Another way is a time series graph. Now, here's the thing with that. Okay. It's a line graph, so we're getting away from bar graphs. Now it's a line graph, which means it's a bunch of points connected by line. But it's very specific that whatever's happening, whatever we're counting, is occurring over time. And so our x-axis is going to be time. Okay? And here's an example of what that's going to look like. Now, notice at the bottom we've got time. We're measuring temperature over a 9-hour period. And this is important too. Have you noticed that they all have a title? So this would be at probably noon. and then 1 o'clock in the afternoon, 1 p.m., 2 p.m., 3 p.m. because the temperature is rising, and then it starts falling as the sun goes down. So we're looking at it in terms of time. We connect those dots to get a better picture of what's happening with the data. The reason I say this is probably 12 p.m. and this is the afternoon is because it's rising. And typically what happens when the sun is up, the temperature rises. If this was midnight, the temperature would expect it to be falling as we get closer to the morning, and then it would rise again as the sun's coming up. So we would expect this thing to be flipped over if this was 12 a.m. instead of 12 p.m. Okay. Really, it's just a specific line graph over the course of time. And you're going to have to make some of these in your homework tonight. Next one, you're familiar with already, pie graph. And we need to talk specifically about how to come up with each segment of the pie and the pie pieces, so to speak. And I'll talk about that in a second here. Here's an example. I realize it's blurry. I apologize for that. Just had to blow it up so you could see it. But notice each sort of pie piece has a percentage attached to it. And I want to talk about how you calculate the size of each pie piece. Okay. Now, for this particular example, there's some store and apparently they're taking a survey of the marital status of all the people that work at the store. Half of them are married. 18% are single, 27% are divorced, and 5% are widowed. Apparently there's no other status. There's no it's complicated. That's not an option, sorry. At Brown's department store, you had to pick one of the four. Okay. You know how to find percent, right? I'm taking the total number in that category, dividing by the total number. Then I'm going to convert it to a percent. Now what's key here is how do you know how big to make the pie piece? Well, how many degrees are in a circle? 360 degrees. So in this case, if half the people are married, then I would go half of 360, which is 180 degrees, and I would make a 180 degree angle for that pie piece. 180 degrees is just going to be a semicircle, right? For these other percents, I'm going to have to multiply that by 360 to decide how big the angle needs to be. Okay? So when you're getting to the place where you're going to be creating a pie graph, make sure you show me that work. Show me how big the angle is going to be, and in some cases, you might even label it. Okay? I'm not saying you have to, because obviously this is a little bit bigger than 90 degrees, but I think when you do that work to show how big the angle needs to be, and you use whatever kind of protractor you're going to use in order to make those pieces, it will be helpful for me in case you do something wrong that I can see what you did, so I know why your wedge or your pie piece is not quite accurate. Okay. Of course, in this case, it doesn't help that we don't have actual data to do that calculation, but I know you know how to find percent. We've already done it before from a frequency distribution. Now it's the next step of multiplying that by 360 to figure out what central angle we need to have. And so that's key too, is it all comes from the center of the circle. So these angles are all central angles. Just some old geometry stuff for you there. All right. The next thing is really not a graph. It's a different way of organizing your data. Because we've looked at frequency distributions as really the only way to organize our data. At this point, we're going to look at another way to organize data, and that's with a stem and leaf plot. And you maybe worked on stem and leaf plots a little bit in middle school at one point when you did a little statistics unit. How many of you remember or have heard of stem and leaf plot? Raise your hand. Okay. Well, some of you, so that's good. So this will be new for a lot of you. Again, a stem and leaf plot is about how to organize your data. And there's actually several sentences. You can sort of see I covered it up over here, but not so good. there's words under there. So it's just going to kind of continue, and I just broke it up a little bit at a time. So it's a table where each leaf contains the last digit of each number. This is going to make more sense when we see all the data. So think about a tree branch, okay? Your tree branch is sort of your stem, and the leaves are all parts, extensions of the tree branch, right? And so that's what this is all about. The stem, the leaves are all the last parts of the number. Okay? The stems are the first part of the number. The remaining digits, the front parts of the number. So what we're going to really do is divide our numbers up. We're going to chop them up and group them. And the number of leaves is the frequency for that particular class. And each stem equals a class. Okay, so the class limits will contain all of the stems. And then the next stem will be the next class limit. And when I show you the data, it'll make more sense. Here's the data that we're going to be using. Okay, you can write all those down. You can take a picture. Either one's fine with me. Now, I happen to choose some data that was already sorted for us. Most of the time, it won't be sorted, and you'll need to sort it. Okay, notice how they go in order from smallest to biggest. Most of the time, that's not going to happen. Just for the sake of time, I picked a set of data that was already ordered. Now, again, if we look up at this definition of the leaf contains the last digit, the 2, the 3, the 4, the 0, all the last digits are going to be the leaves. The remaining digits, in this case, are going to be the first number. Okay, so what I want to do after I put the data in order is to organize it and sort of split it out. Okay, so I split it out in terms of zeros. So I have 0 as a leading digit. I have 1 as a leading digit. I have 2 as a leading digit. 3s as a leading digit. 4s as a leading digit. 5s. So I separate them out because that first digit, since they're all two-digit numbers, there's only going to be 1 digit in the stem and 1 digit in the leaf. There's always just 1 digit in the leaf. Let's put it that way. There's always just 1 digit on the leaf, because it's the last digit. Okay, the stem could have 2 digits, 3 digits. If these numbers were in the hundreds, then the stem would be 2 digits. If this number was in the thousands, so let's say my data was all, I'm just going to pick that. So this is going to be the leaf. This is going to be the stem, the 3, 4, 5, the remaining digits. Okay, so in this case, because there are only 2-digit numbers, the last digit is the leaf. The first digit, because the first digit is all that's left, is the stem. Now in the next slide, I'm going to show you how to construct the actual stem and leaf plot. This is the first part where we're just organizing it. So when we go to draw the stem and leaf plot, it's going to look like this. My stems are going to be 0, 1, 2, 3, 4, and 5. And I don't have to repeat them. And here's why the stem and leaf plot is sort of helpful. It helps us put the data together in a more concise way. Because these are all the zeros. These are all the 10s. These are all the 20s. These are all the 30s. So when I go to my stem and leaf plot, that's what this represents. The zeros, the 10s, the 20s, the 30s, the 40s, and the 50s. Okay, so that's the first part. This is the stem on the left. The leaves are all the other digits. So we only had one number that started with 0. Okay? And what was that? 2. So I'm just going to put a 2 here. Okay? How many digits, how many numbers, how many data started with 1? 2. What were they? 13 and 14. So I put a 3 and I put a 4. Okay? So this indicates 2 data points. 13 and 14. Go ahead and finish it. So here's what it should look like. Now, I noticed some of you are putting commas in between. That's totally fine. Here's the point of emphasis I want to make. Notice the spacing. Notice how uniform it is. The second digits are all in the same place. So think about when you were adding numbers, when you first started adding numbers, and keeping place value in the same spot. Hundreds over hundreds, thousands over thousands. That's really important here. Because right away, we can see a trend just by looking at this. It almost looks like a graph, right? Where's the bulk of the numbers? In the 30s. I can just see that just by looking at the stem and leaf right in here. Because this sort of, there's a whole bunch of numbers over there. If you cram those numbers all together, because you're trying to save space, you're not going to see the dramatic difference between the amount of data in the 30s versus the amount of data in the teens, for example. Okay, so keep your spacing. Even if you put commas, that's fine. Just keep your spacing so that all of the second digit from each stem line up. All of the third digit in the third data value line up. Okay, keep that spacing nice so that when it comes down to making conclusions from the data, we can kind of see what's going on. Okay? How many have done one of these before? All right, most of you haven't, so that's good. That's going to be new for you. Tomorrow we're going to talk about a double-sided stem and leaf plot where we can take 2 sets of data and put it on one stem and leaf plot. We'll talk about that a little bit. Okay? So just to kind of see, we start with our original data. This is where we're going to end up. Again, it's a way of organizing it. Now, one of the other things that's important, and like I said, it worked out okay for this one because it was already in order. Make sure you put your data in order from smallest to biggest first, because these numbers also need to be in order. If these numbers were scrambled up so that they weren't in order, we're not going to be able to use it to find some of our measures of central tendency that we will find in chapter 3. Okay? And we include as many times as 32 got repeated. We put 4 of those. Okay? Any questions about any of these ways to display data?